Hi everyone! In this video, we are going to talk about the graphs and properties of basic trigonometric functions. When we say properties, we are going to describe the graphs of these basic trigonometric functions according to the following criteria: their domain, their range, their periodicity, whether they're odd or even, their x and y intercepts if any, and lastly, their vertical asymptotes if they exist. You have had this criteria when you were having your ninth grade math, but a little recap wouldn't hurt. So let's have one. First, the domain. The domain is the set of all possible input values of a function for which the function is defined. So when we talk about the function f of x, we get all the possible values of x that makes it defined. That set of numbers is the domain of f of x. If there are values that make f of x undefined, we exclude it from the domain of the function. We can determine the domain of a function by looking at the x-axis in its graph and looking at the values that the graph covers. Second criterion is the range. The range is the set of all output values in a function after considering all its input values. So these are values of f of x after you put in all the input x. In the graph, you can look at the y-axis and look at the range of values that the graph covers. The third criterion is the periodicity. The period of a function is the length of its cycle. This means the value for which the cycle will keep on repeating itself. As we know, trigonometric functions are cyclical, so they will keep on repeating themselves. Thus, knowing their period is very helpful. The fourth thing to do is to determine whether they are odd or even. We know that an odd function is symmetric about the origin. This means when we fold the graph along the y-axis and then fold again along the x-axis, the parts of the graph will coincide. On the other hand, an even function is symmetric about the y-axis. This implies that when we fold along the y-axis, we will see the parts of the graph coincide. Fifth, we have the x-intercepts. These are points where the graph crosses the x-axis. This means that at these points, the value of f of x, or y, is 0. The graph may also have y-intercepts. These are points where the graph crosses the y-axis. At these points, the value of x is 0. Lastly, we will consider the vertical asymptotes of the graphs if they exist. Note that vertical asymptotes are vertical lines that the graph approaches but never intersects. We express vertical asymptotes as equations of the vertical line. So the goal is to examine the graph of each of the basic trigonometric functions and complete this table of properties afterwards. Let's go to the first trigonometric function. First, we have the graph of y equals sine x. You see its graph plotted using the GeoGebra app. Take some time to look at it. Afterwards, let us examine its properties. Let's look at its domain. We notice that even when we extend indefinitely to both the left and the right part of the graph, there will be no value of x that will make it undefined. Thus, the domain of y equals sine x is the set of all real numbers. What about its range? Does it also extend indefinitely upward and downward? We don't see such case here. We know that the minimum value is -1 and the maximum output value is +1. Thus, the range of y equals sine x is from -1 to +1 inclusive. Let us now go to its period. When we look at the graph, we know that it will keep on repeating itself after 2 pi. Thus, the period of the graph of sine x is 2 pi. Let us now check the points by which the graph intersects the x-axis. We observe that the graph intersects the x-axis for every x which is the multiple of pi. That means it intersects the x-axis at 0, pi, 2 pi, 3 pi, and so on. On the negative x-axis, it will intersect the x-axis at -pi, -2 pi, -3 pi, and so on. Thus, the x-intercepts of this graph is n pi, where n is an integer. After checking the x-intercepts, we now go to the y-intercept. There is only one point by which the graph intersects the y-axis, and that is when y is 0. Thus, the y-intercept is 0. Now let us see if it is odd or even. If we fold along the y-axis, it will not correspond to itself. But if we fold again along the x-axis after doing that, we know that its parts will correspond to themselves. Thus, we know that it is symmetric about the origin. This means that the sine function is an odd function. Lastly, let's check its asymptotes. Since the graph of the sine function is a continuous function, it doesn't have any vertical asymptotes. We now summarize the properties of the graph of the sine function in one table. In your learning guide, you will find a summary of all these properties for all of the basic trigonometric functions. Let us go to the second function, our cosine function. We also plot its graph using the GeoGebra app. We will examine its properties one by one. Let us look at its domain. Similar to the sine function, we notice that even when we extend indefinitely to both the left and the right parts of the graph, there will be no value of x that will make it undefined. Thus, the domain of y equals cosine x is the set of all real numbers. Now let us look at the range. As we can see, the range of the cosine function is also from -1 to +1 inclusive. By examining the period of the cosine function, we know that it will repeat itself after 2 pi. Thus, the period of the cosine function is also 2 pi. While the sine function is odd, the cosine function is even. This means that when we fold it along the y-axis, its parts will correspond to themselves. Let us also determine its x-intercepts. We see that the graph crosses the x-axis for every odd multiple of pi over 2, meaning when x is equal to pi over 2, 3 pi over 2, 5 pi over 2, and so on, as well as their negative counterparts, the value of f of x is 0. We would also like to determine its y-intercepts, and we see that it crosses the y-axis only when y is equal to 1. Thus, its y-intercept is 1. Similar to the sine function, the cosine function also doesn't have any vertical asymptotes. We also summarize the properties of the cosine function in one table. Third, we have the graphs and properties of the tangent function. We also use the GeoGebra app to plot its graph and observe its properties. Unlike the sine and cosine functions, the tangent function isn't continuous. This implies that the domain will not be the set of all real numbers. As we see in the graph, the tangent function is not defined when x is equal to an odd multiple of pi over 2. Thus, we exclude all such values from the domain of the tangent function. Looking at the range, we see that the function extends indefinitely both upward and downward. Thus, the range of the tangent function is the set of all real numbers. Unlike the sine and cosine functions, the period of the tangent function is pi. This means that the function repeats itself after pi. The tangent function is also an odd function, which means it is symmetric about the origin. Let us also determine its x-intercepts. We see that the graph crosses the x-intercept for every multiple of pi, meaning when x is equal to 0, pi, 2 pi, 3 pi, and so on, as well as their negative counterparts. Looking at the y-intercepts of the tangent function, we know that it only crosses the graph when y is equal to 0. Thus, its y-intercept is 0. Unlike the first two functions, the tangent function has vertical asymptotes. The graph approaches the lines x is equal to n pi over 2, where n is odd. So we have x equals pi over 2, x equals 3 pi over 2, and so on. Of course, we want to summarize the properties of the tangent function in one table. Fourth, let us go to the reciprocal of the sine function, the cosecant function. Like the first three functions, we plot the graph of the cosecant function and examine its properties. We do the same procedure to determine the domain of the cosecant function. As we see, it is defined for all real numbers except those that are multiples of pi. Thus, we exclude 0, pi, 2 pi, 3 pi, and so on, as well as their negative counterparts from the domain of the cosecant function. In the graph, we see that the range of the cosecant function is from negative infinity to negative 1 and 1 to positive infinity. Negative 1 and positive 1 are both included. Like its reciprocal, the period of the graph of cosecant function is also 2 pi. Moreover, like the sine function, the cosecant function is also odd, which makes it symmetric about the origin. We don't find any x-intercepts in the graph of the cosecant function. We don't have any y-intercept either. However, the cosecant function has vertical asymptotes. They are x equals n pi, where n is any integer. We now summarize the properties of the graph of the cosecant function for your reference. The fifth function that we are going to examine is the secant function. We also plot its graph and examine its properties. As we see, the domain of the secant function is the set of all real numbers excluding the odd multiples of pi over 2. At such values, the graph is undefined. Like the cosecant function, the range of the secant function is also from negative infinity to negative 1 and positive 1 to positive infinity. Negative 1 and positive 1 are both included. The period of the secant function is also 2 pi. Like its reciprocal, the secant function is even, which makes it symmetric about the y-axis. Similar to the cosecant function, the secant function has no x-intercepts. However, unlike the cosecant function, the secant function has a y-intercept, which is 1. It also has vertical asymptotes, which are lines that come in the form x equals n pi over 2, where n is odd. We also summarize the properties of the graph of the secant function for your reference. Last among the functions that we are going to examine today is the cotangent function. We also plot its graph and examine its properties. As you see in the graph, the domain of the cotangent function is the set of all real numbers except integral multiples of pi. At such values, the function is not defined. Like its reciprocal function, the range of the cotangent function is also the set of real numbers. Similarly, the period of the cotangent function is pi. It is also an odd function, which makes it symmetric about the origin. Moreover, the graph crosses the x-axis at odd multiples of pi over 2. However, it has no y-intercepts. The cotangent function is asymptotic to the lines in the form x equals n pi, where n is any integer. Now we present the summary of the properties of the graph of the cotangent function. So there you have it, the properties of the 6 basic trigonometric functions. The summary of all these properties may be found in your Khub course under the learning guide with title Graphs and Properties of Basic Trigonometric Functions, Part 2. I will also put all the links and references in the description box below. Please feel free to comment and also subscribe in this YouTube channel. Thank you and see you in the next video.